Hear me?
Yep,
Yeah.
perfect.
Okay, perfect. Good afternoon, everyone, and thanks, Thomas, for organizing this workshop. So I will try to talk about lessons learned from experimental dune notching in southwest France in the frame of a project that finished about 4 years ago, which involved quite a lot of colleagues listed here. And yes, most of the results I will show here have been produced by Quentin Laporte-Forêt, who did his PhD in the frame of this project and who is now postdoc in the US. So yes, we go further south, and we are interested in here the coastal dunes of southwest France, which cover approximately 250 kilometers of coastlines here. That's a relatively straight coast, just interrupted by the Arcatian Lagoon here. And it is commonly perceived as a pristine kind of natural landscape, but actually these coastal dunes, this landscape is largely inherited from previous human intervention over the last 150 years. And these interventions are synthesized here. So in short, a few centuries ago, the coast was made of very mobile coastal dune systems migrating inland by kilometers. And so in the middle of the 19th century, this entire coastal dune system was fixed by pine trees. And then to protect these forests, the western part of the mobile dune was fixed by progressively rising 2 rows of fences. And it was followed by marram planting. Then subsequently, in the next decades, these coastal dunes suffered severe aeolian and marine erosion. They also serve as a source of aggregate for the Germans during the Second World War. And so after the Second World War, these coastal dune systems were in complete disrepair. And that's only in the 70s, 80s that an engineering coastal dune profile was imposed mechanically, followed by, once again, intense marram planting. So here you have some pictures of this large-scale work. It has been done across 250 kilometers of coastline. So you have this mechanical reprofiling, giving rise to this big engineering dune profile. You can see the marram planting here and there, and the landscape just a few years after that. And nowadays, if you go on the coast, this current landscape is largely inherited from this work. And it's easier to see here from ground-penetrating radar data, where you can see here the location of the two fences in the middle of the 19th century, here the engineering profile. And on top of that, you have the slowly building foredune. So you can say that, okay, this kind of landscape is fine, but actually there are two shortcomings from the perspective of biodiversity and morphodynamics. The first one is that, as you can see here, the dune profile is strongly uniform along shore, as you can see here on the left. While we see that change in topography result in variety of exposure to salt spray, to wind, to sediment transport, to rain. And this is strongly linked with the diversity of microhabitats and landscape diversity to the right. So it is very likely that more three-dimensional coastal dune systems are characterized by more diversity. The other issue we have with these coastal dunes, it's rather in chronically eroding systems. So here you have a figure showing the latitudinal distribution of the long-term shoreline trend along the southwest coast of France. So you can see that most of the time it's stable or slightly eroding, except close to the Arcatian Lagoon and the estuary mouth here, where we have strong accretion and erosion. So when we have stable coasts or accreting coasts, such as here, these engineering profiles are not that a big deal. But if we go to chronically eroding sectors, the beach can even disappear. And the reason for that is that so we have such big dunes that in chronically eroding sectors, we have the formation of high erosion scarp, sometimes more than 10 meters high, and they act as a barrier, and they prevent the natural beach dune sediment exchange. So the sediment from the beach cannot be transported to the back of the dune. And eventually, the dune can disappear and expose the hinterland to flooding. In contrast, coastal dunes maintained as dynamic system can migrate slowly landward, accommodate, and safeguard the hinterland. So the issue is, how do we initiate and maintain such kind of dynamics of the coastal dunes? So it has been told already today, notches or natural browse are a natural kind of conduit that is able to transport the sediment from the beach to the back of the dune. Like in the UK here, we also have quite a lot of blowouts which are actually connected to the beach. An issue is that for the last 40 years, the coastal dune stakeholders of southwest France have been kind of fighting these blowouts to limit the mobility of the coastal dunes. So it has been quite a long and very interesting process together with the stakeholders to develop a research project, largely inspired by what was going on in the Netherlands with Herben Racing to explore how we can mobilize the coastal dunes and what are the effects on the morphology, but also on the biodiversity. So part of this project, we had a field experiment that occurred at Trucver Beach, which is located here. That's quite a stable sector of the coast where we do not have that many blowouts, but at least that was a site where we have quite a lot of data, and we could excavate notch a little bit as we wanted. So we divided that 4-kilometer coastline into 500-meter boxes. And in each boxes, we excavated a notch in the incipient foredune and a notch in the foredune. And we tried to have dimension of notches quite similar from one block to another. And we followed the evolution the next 2 years. So for the morphology, so that's kind of a classic kind of survey techniques. We used photogrammetry from UAV flights. So we run UAVs with automatic flight plan and permanent ground control point to have perfect replicability between two surveys. And you can see that we can, from that, have some very good insight into the high resolution change. As you can see here, the building of the incipient foredune, the smoothing of the crest, and the building of the foredune here, which also slightly migrates inland. What we had, and I forgot to mention that compared to the Netherlands and to the UK, the dimensions of our notches were ridiculously small. It was very, very small. But despite that, we managed to see some morphological changes, and particularly the formation of a deposition lobe. So we've seen that these notches, and particularly the notches excavated in the foredune, increased sand transport from the beach to the back of the dune. And what we can see here with the time series of the lobe volume is that this increase in volume mostly occurred during the second winter, the winter of 2019-20, which was particularly windy, while during the winter of 2018-19, which was particularly calm, nothing much occurred. So winter storminess for this kind of notch, at least, is very important to the efficiency of this notch to be a conduit for the sediment transport. This is a slide that says a little bit the same story. That's different plot from the first winter, the second winter, and the cumulative difference plot. Once again, you can see that we have much more morphological change during the second winter. And you can see also that there is quite some alongshore variability and the signature of the notch, but we also have landward migration of the foredune where there is no notch. In terms of vegetation surveys, so the plant community composition and cover was estimated using quadrats. So that's this 1 meter square quadrats here that we used along the entire profile through 13 different dots. So from the beach, incipient foredune, established foredune, transition dune, and gray dune. And we did 4 transects in each block. So 1 transect across the established foredune notch, 1 across the incipient foredune notch, and 2 control transects. And we determined the occurrence of different vegetations. I think we had over 15 species. So I'm not a biologist. I will just show one result here, which presents the change during the winter of the species richness. So during the winter, the low energy winter in blue and the high energy winter in red. For the control transect starred and for the foredune notch transects squared and the incipient foredune transects circled. And this is from the beach here to the back of the dune. So what you can see is that there's not much difference in terms of species richness during the low energy winter, but in contrast, during the high energy winter, we have an increase in species richness across the entire beach dune system. And more importantly, we see clearly an increase in species richness landward of the foredune notch. So it drove actually a regeneration of the vegetation. So what are the implications here? So this is a very limited kind of survey. We have only 2 years of data. We have more data now, especially from the morphological point of view. What are the implications? So first, now coastal dune stakeholders run more large-scale remobilization experiments in chronically eroding sectors. So that's here an example. And interestingly, instead of excavating notches, what they do usually is they do some sort of clipping of the crest of the dune, which makes it easier to remobilize the dune on larger scales. Another thing which is quite important, remember I told you that a few centuries ago, the coastal dunes were just bare sand dunes moving inland by kilometers. And you can see here that it will be the case nowadays too. That's here a military domain where the coastal dune has not been managed for the last 50 years. And in contrast, here you have the managed coastal dune domain. And you can see how the coastal dune can migrate landward with absolutely no vegetation here. So of course, we want to limit that. And this is why with colleagues from the coastal dune stakeholders and BRGM, we are also currently running experiments to make different approaches to stop or limit the dynamic of these coastal dunes. So that's an example of an experiment we have done over the last winter, and we will continue to monitor the morphological changes in the next years. So to conclude, these small-scale excavated notches in southwest France, they modify coastal dune profile and vegetation cover, but it really depends on dune compartment. We see that there is more efficiency for the foredune notches. I do think that we will have completely different result if we had performed this experiment in chronically eroding sectors. These notches increase sand accretion and landward transport, and they drive landward plant community rejuvenation by sand deposition. And in terms of coastal management implications, we are now running large-scale remobilization actions in some chronically eroding sectors, and we also do experiments to better understand how to manage this enhanced dune dynamics. And I think that's all for me. Thank you.